Hello, everyone, and welcome back to the second live stream for LiveCTF. And I am hearing myself, so I need to sort that out.
Do you have the stream open?
I do have the stream open.
Yep, that's a classic.
I no longer have the stream open. Welcome, everyone. Hi, I'm Carl, or Seda2, here with my fellow LiveCTF organizers. And
Yeah,
we have
hi.
Glenn and
I'm
Mark.
Glenn. I'm the guy who wrote the challenges that you're gonna be enjoying right now.
Nice.
And Mark.
Yeah.
Later.
So what has just happened? We had the first challenge, Robably. That was one written by me. It closed 1 hour ago, and we had 24 solutions submitted, 24 valid solutions submitted to us for that one, with the first one coming in already after like 20 minutes. So that was quite impressive. And also at the same time as we closed that challenge, so 1 hour ago, we also opened the second challenge, which is, as Glenn mentioned, written by him. And so that one has been open for an hour right now. Currently, I'm going to double check
someone
that
solved
actually.
it 5 minutes ago.
Oh, okay. It was just solved. When we were setting up the stream, it didn't have a solve. So now it does have a solve.
Congratulations
Nice.
to Never Stop Exploiting. I guess we'll be
Yeah.
seeing that in a couple hours.
Great job. But let's not get ahead of ourselves. We will talk about that one in the next stream. Now we're going to talk about Robably. So this challenge was a reverse engineering challenge, classic end cuts style. You are served a number of crack me's, and you need to provide the password for each of them. So presumably you need to build some kind of script to automatically solve the crack me. And I'm just going to show what one of these crack me's look like. So if you open this in Binary Ninja, you see that there are like a whole bunch of functions, and they're all short snippets, and they all have this form where they start with this. No, sorry, I need to actually switch the view to show the viewers. Now, here's my screen being shared. Here's Binary Ninja with one of the samples open. So the players were given 20 samples. I believe there were like 200 or something in total on the server, and the players had 20 to kind of test their solution locally. So the challenge is full of these small chunks of code, each starting with an instruction swapping the RBX and RSP registers, doing the same thing again at a return. And all of these functions are then also, the addresses to them are in a table. So basically what this is a ROP chain executing some code, performing the check. Glenn, you did a test solve of this one when we did our internal work. So what was your approach?
So I saw a whole bunch of gadgets. I saw that if you scroll down to the main function in there somewhere.
Yeah, let me get a main function. Yes.
Yep.
Yeah.
It calls out to a second helper function.
Yep.
Which then did a whole bunch of weird stuff with this stack and then compared a thing. Yep. And I looked at this and I was like, okay, it's setting this stack to some data address. Quickly found out that trying to load ROP code into Binja is not super supported. Wrote a whole bunch of stuff to try to like see if I could get Binja to analyze it. I was like, nah, not really. So then I just threw it to the tried and true anger. Oh, what are you doing in there?
I'm just
up in the
trying
font
to
size.
increase the font size a bit.
Yep.
But
there's actually 2 font sizes.
Man, you
want the view font size.
Oh, here we have it. Yeah,
there you
nice.
go. There you go. Ask me how many times I've done that on a presentation. So
yeah.
So I looked around at the gadgets. I realized, hey, it's doing a whole bunch of stuff. I don't think I have this open anymore. I scripted up a quick thing that put all of the addresses that were being like in the stack, it pushed them, and then it called, or then it returned. So then Binja can like basically analyze the ROP chain as if it were a function. And then I looked at it and I'm like, oh, it's doing a bunch of constraint solving. I can't automate that with Binja. And so I just like switched to Anger.
Yep.
Which is the classic.
Yeah. And actually, if we do take a look at some of the solutions from the teams, so we have here a bunch. I feel like
shout outs to the Anger people, by the way. They are very cool. And one of them gave a talk at our conference that my company ran this year, so that was very cool.
Nice. Yeah, Anger is very nice.
What a good tool.
I actually learned a little bit more about it while building this challenge because I had to solve it.
I learned more about it while solving your challenge.
So I've been looking through these solutions from the teams, and I'm seeing kind of two main themes, basically. Some of them, let's see if we can find an example of that.
You've managed to pick one that doesn't use Anger.
Yeah, so here is a pretty, I would say, pretty vanilla Anger approach, right? So we can see that they're like,
size?
Yes, I should increase the font size a bit more. This is maybe even,
there we go.
Maybe even that. Yeah. Let me just remove this a little bit. Right. So it follows kind of like a very common approach with Anger, right? We load up this thing, we create some symbolic data containing the password that we're after. We set up our state like to run the program, and then here they actually seems like they're hooking getLine, I guess, to set up the symbolic memory in this case. And then they basically here doing an explore and looking for, so the binary will print yes or no. So they're just looking for that in the output, and that is their determination whether it's succeeded or failed. And then they run this, and there you get. So this, yeah, very kind of, I mean, relatively
pretty
speaking,
standard
simple
stuff.
Yeah, exactly. There are a bunch of variants on this. I would say this is maybe as simple as you can make it, or very close to. I've seen some variants on this. There is also, let's see if we can find, I think Sauercloud had kind of like an in-between approach. Let me go down to Sauercloud. Yes. So what I think, if I understand this correctly, what they are doing is that they are opening the ELF file, and they are reading this ROP chain table thing and finding all of those gadgets, and they're putting all those gadgets together, and then so they basically reassemble the original function, and then they use Anger's ability to just load a snippet of code as shell code, and then they run Anger on that. So they don't do like a full black box kind of approach with Anger. They first do some manual deobfuscation, and then they run the run Anger on that, which is very similar to what I did in my reference solution. So that's cool to see.
Yep.
Tell me you used object dump.
I did not. I used, like, in my solution script, I had capstone, keystone, leaf, and Anger in my solution script to manage
the 4 horsemen of the reversing dynamic reversing apocalypse.
Yeah. So I would say, and then there are variants of this, but I would say this is kind of in, let's say, in the one big main theme of just using Anger, you see kind of like just a pure Anger solution, and this kind of, first we do some pre-processing and then we use Anger. The other kind of main theme is, I think this is an example of it. Let me check. Yeah. So basically, the other main theme is basically reinventing Anger. So what I believe they are doing here is that they are essentially, let's go down a bit and see how they drive this. I think they're basically parsing this table with these gadgets, and then finding the various instructions that are relevant.
Oh my god, they're disassembling it by hand.
Oh dear, yes. Oh yeah. They're not using. Oh, there's no capstone in here.
No, there's no capstone. They're just doing it by hand. Congratulations.
It's just byte comparison.
They reinvented Anger, but a little bit less featureful and a little bit more.
Yeah, so they create these instruction objects, which they just extract all the interesting information, and then they shove this all into C3. I guess they have some.
Oh my god, they
Python
put it into a Python script and then they execute it. That is a choice.
This is CTF grade code. Okay, yeah.
No, because they're just taking they've taken the patterns in the disassembly and turned it into what the Z3 equivalent is what it looks like.
Are you telling me they're disassembling the bytes and then turning it into Z3 constraints and then solving it? If only there were a tool that
no
did that.
disassembly. No disassembly. They're just pattern matching the bytes.
All right.
Yeah.
I mean,
here's another example of a similar approach, right? This one using capstone. So kind of, we see here a C3 solver looking at the input, and then here parsing. And they basically have a bunch of different like patterns that they're looking for. By the way, to the author of this code, did you know that Python now has like switch statements? Yeah.
I mean, this is like the same approach, right?
Just yeah. They
use capstone.
Exactly.
They matched off the disassembly.
Yeah. So they're doing the same thing. We're parsing the gadgets, doing the disassembly, matching on a couple of relevant instructions, and then creating the constraints, and then putting all that into C3. So this is basically the other kind of main theme we see among the solutions. I think there was one other that was interesting, and I think that was MMM here, because they are using Triton and not Anger. And I have actually never used, like, I've seen the name and I've maybe like read like the front page of the website of Triton, but I have actually never used it. Have any of you, like Mark, have you used Triton?
I have
not. So I can't comment that much about it, but I vaguely know of it, and it's a different like dynamic analysis framework. And I mean, just kind of skimming through, what the API looks like and so on, it looks kind of interesting. So definitely something I'm kind of interested in checking out after this. So they're basically, what are they doing here? They are creating some Triton context, setting up some concrete values, some symbolic values. Then we get capstone. Are they reading? Yeah, ROP pointer. Yeah, so they're also doing this kind of hybrid approach, I guess, where they are taking each gadget and I guess then putting this together into Triton and getting the password.
That's cool. I like that.
Mm-hmm. Yeah.
Yeah.
It's very nice.
Same idea, different tools.
Yeah. But it's really cool.
That's something I'd like to see, though, is, how many different symbolic executors are out there? And granted, people are under time pressure, so they tend to use what's popular or what they know, but it's really cool to see somebody picking something besides Anger.
Yeah. I saw some team had like, oh yeah, you can see some are LiveCTF veterans. They have these like shorthand functions in Pwn.
We've certainly seen those in the finals before. People just show up with an entire thing.
Like, oh yeah, this is Macaroni.
Oh, and Macaroni are great.
the file is named a.py. We don't want to waste any characters.
Nope, just go right
writing
at
longer
it.
file. Yeah, I like it.
Micro optimize.
And they also went for an anger approach. I'm just kind of skipping over the ones that look like similar approaches that we've already kind of seen here.
What was the distribution of solve times? Did we have a vague sense?
I think we can go back and check, but I would say it was like a fairly steady stream. Starting at those 20 minutes, and then it was kind of like
15-20 minutes till the first solve, and then a whole bunch were piled up around hour 2. Like I see 5 to 6 solves within 10 minutes.
Yeah.
And then the last solve was like 45 minutes before the close, so no one squeaked it in.
Yeah. And with that, just maybe we should just go quickly to just the scoreboard generally for the CTF. Let's refresh.
Oh wow, is MMM on top?
Yes.
Who could have predicted that?
Well, they have not been on top throughout the whole qualifiers, I will say.
Okay.
Hype Boy have been in the first place on multiple occasions. But yeah, we do
if MMM
see
gets first place, I get to check off a square on the bingo. So.
Oh, you're doing a bingo thing. I will say shout out to this team. This is the Swedish national hacking team. They were the first ones to solve the challenge. So you can start throwing the accusations of me being biased with this, or leaking solutions to them or something. But no, they were really cool. They solved it within, I think it was 21 minutes. So that was really impressive to see. And yeah, they are down here in 18th place, but I believe in them. But yeah, we have up here in the top MMM, Hype Boy, Super Dice Code, Macaroni, Organizers, all very familiar names for people who have been around for a while. Yeah, and as we mentioned before, Glenn, one of your 2 challenges is live, and we have at least 1 solve.
Yep, so far I got 1 solve, Never Stop Exploiting. The challenge is Unwind Me Maybe, and well, you can read the description on the page. I'll give you more details on it in a couple hours. But
yeah,
I hope some people are having a good time reading documentation.
Yeah.
Every
That's
single
what
one
they keep
of them
coming back for.
Every single one in this XYZ Me Maybe series, it's just like, did you know that you can get code execution with this?
See, but you're digging up these esoteric ways to give people arbitrary execution and really educating,
Yeah,
people
I
that
got
really
to close
care.
so many Firefox tabs after I solved this one.
I mean, the whole series started with the Sys Call Me Maybe 3 years ago.
The pun doesn't even work anymore. The pun has long since passed.
Yeah. All right. I think this wraps up this second stream for us. Any closing words before we let the players back to hacking?
Good luck, teams. Hack harder.
Keep hacking.
Nice. Goodbye, everyone, and see you in about 3.5 hours. Bye.